Alright, welcome back to another episode of Math with Mr. Young. So today we're going to be working with 7.2 areas of triangles. Our standard is 6th grade Geometry A, and our objective is that we're going to be able to find areas and dimensions of triangles and find areas of composite figures. Our mathematical literacy, we have composite figure. Alright, today we're going to work with 7.2 areas of triangles. Our success criteria is that we're going to be able to explain how the area of a parallelogram is used to find the area of a triangle. Keep note that we're going to be using area of equals base times height for a parallelogram, but of course dividing it in half. We're also going to be able to use the base and the height of a triangle to find its area, and use the area of a triangle to find one of its dimensions, and of course find the other dimension. And then also use decomposition to find the area of a composite figure. Alright, as usual, we always start off with our mathematical literacy, our vocabulary words. Now, a composite figure. This is a figure that is made up of triangles, squares, rectangles, and other two-dimensional figures. To find the area of any composite figure, you have to separate it into separate figures with areas that you know how to find, and that is called decomposition. For an example, alright, let's say this is a swimming pool, and it told me to find the area of this swimming pool. And let's say that for this side of the swimming pools, let's say it's 30 feet. This side of the swimming pool is, let's say 30 feet again. Here would be maybe 20 feet, and then of course 20 feet. Alright, so find the area. Now again, we have a composite figure. Okay, so before I get into that, let's talk about dimensions. So if I have a dimension, let's say like that, that would be the length. Okay, one dimension would be a length. Okay, we also know that as the x-axis. Another dimension would be the height. How tall is something? Okay, that would be the y-axis. So in this case, if we have a two-dimensional figure, if we have this two-dimensional figure, this is two-dimensional. Okay, we have a length and we have a height. The length is one-dimensional and the height is one-dimensional. And what's 1 plus 1? Well, 2. So there's two dimensions. Length is a dimension and height is a dimension. So I just wanted to repeat that. Okay, so that was just an example of what I'm talking about as far as dimensions go. Okay, we're not talking about anything else. All right, so we have this composite figure here, and again, we're just going over vocabulary words. So again, this is it says that composite figures are made up of triangles, squares, rectangles, and other two-dimensional figures. Okay, so this is not the third dimension. You just have a length and a height. We don't have a depth, so we don't have the z-axis, just x and y axes. All right, so let's break this up into other shapes. Well, if you look here, you can actually break it into one long rectangle and one triangle. So let's find the let's find an area for this. So let's say that so the whole thing across is 30 feet, and if you look here, 4 and 4, so half of 13, or half of 30 would be 15 feet. So again, you just multiply. The area of a square would be area equals base times height. If your base is 15 and your height is 30, 15 times 3 equals 75. Add that 0, so this is going to be 700 feet, 750 feet squared, just for this rectangular part here. Okay, Now, we're going to find the area for this part. Again, this is 15 feet. So again, the area formula for a triangle is going to be area equals base times height divided by 2. Okay, so again, your base is area equals, let's see here. So let's say that this is the hypotenuse. Okay, so 1, 2, 3, 4. Okay, so let's say that this is the base is maybe 15 feet. And then your height would be, then we divide that by 2. We're just going to estimate. Let's just pretend that their height is maybe, I don't know, 10 feet. Okay, and then of course 15 times 10, this is going to be 150 divided by 2. It's going to be 75 feet squared. And then you just add your two areas, 750 plus 75. So that would be about 750 for the area of this rectangle, and then 75, add 5, 2, 1, 8. So the whole area for this whole figure, this composite figure, is going to be equal 825 feet squared would be the area. So you just add those two areas together to get the area of the composite figure. All right, so that's kind of what we're going to be doing today. All right, I want to revisit the formulas. Okay. Area formulas. So we have two different types of area formulas. We have the area formula of a triangle and the area formula of a square. Now we're very familiar with the area formula for a square, and we use that to find parallelograms. Okay, so area equals base times height. Now with this post-it that I have, well, what geometrical shape is this post-it? Well, it's a square. Okay, so it has a base and it has a height. It's a two-dimensional figure. Now the reason why for the area formula for a triangle is area equals half times base times height, because half of a square is a triangle. Check this out. So if I divide this square in half, increase that. So if I divide that in half, and then if I were to pull it apart, well, check this out. Use your common sense, right? Well, we got started there with a line. So again, half of a square is a triangle. Okay, so again, that's the reason why the area formula of a triangle is it's half of the base times height of a square. So half of a square is a triangle. Okay, so I wanted to revisit that. So again, base times height divided by 2, because there's 1, 2 parts. All right, there you go. All right, we're going to find the areas of triangles. So our directions tell us to find the area of each triangle. So here we have two examples, A and B. Right here we have this triangle. And again, triangle. Let's look at that. Triangle. So tri right here means 3. So we're saying 3 angles. So let's draw a triangle. Let's draw 3 acute angles less than 90 degrees. Well, if we look here, we have one angle here, another angle, and another angle. We have 3 acute angles. And if you were to connect those, what shape do you have? A triangle. So again, a triangle, the geometrical shape of a triangle, has 3 acute angles. All right. Okay, so here we go. Again, let's write the formula. The first thing we do is write the formula of a triangle. So again, that's going to be the area equals base times the height, and we divide it in half by 2. Again, bringing this back. The formula for a square is going to be area equals base times height. But again, we divide it into 2 parts. So we divide it in half to get the area formula of a triangle. Okay? So there we go. So let's substitute these values into these variables now. So again, this is going to be A equals base times height divided by 2, area formula of a triangle. So the base here is 5. Substitute 5 inches for the base times the height. It is 8 inches tall divided by 2. So 5 times 8 is going to be 40 inches squared divided by 2. And again, half of 40 is going to be 20 inches squared. So the whole area inside this right triangle, or this right angle, this triangle has a right angle, 90 degrees, but the whole area inside that triangle is 20 square inches. All right, so hopefully that makes sense for you. Now let's look at B here, okay? So B here, we do again have another triangle. So check this out. Inside this triangle, you have an obtuse angle more than 90 degrees. You have an acute angle less than 90 degrees and another acute angle less than 90 degrees. But ultimately, these 3 angles make up this isosceles triangle. So again, this isosceles triangle, if I were to turn this and we look at this triangle here, again, try 3. We have 3 angles, 1 obtuse angle, 1 acute for a total of 3 angles. But again, if you look here, 1 or 2 of these sides of the triangle are of equal length, but one side's a different length. Okay, so this, if we have 2 sides that are equal, then this is going to be an isosceles triangle. All right. Okay, so again, you have the type of triangle, and then you also have the type of angles. Okay, so angles are different from triangles. All right. They also have similarities. Okay, so that's beside the fact. There's a lot that goes into this. So here we go. We're finding the area of this triangle, though. The area of this isosceles triangle. Okay, so here we go. And this is a scalene triangle over here, by the way. None of the sides are of equal length. All right, so here we go. Let's see here. And it has a right angle, by the way. So again, write the formula area. What am I saying? Write the area formula of a triangle. So area equals base times the height divided by 2. Again, because half of a square is a triangle. Okay. One more time. If we have a square and we divide it in half into 2 parts, we have triangles. Okay. So yes, that's why we have area equals base times height divided by 2. All right, so again, let's plug in the information, substitute for the variables. Now our base here is 12 meters times our height, 9 meters, divided by 2. Okay. All right, then we just multiply. So 12 times 9 is going to be 108 meters squared divided by 2. Now again, half of 108 will be 54. That's going to be 54 meters squared. Again, that's going to be the area inside this isosceles triangle. Isosceles because 2 sides of the triangle are of equal length. There you go. Okay, so the area equals 54 meters squared. All right, so that's all there is to it, ladies and gents. So one more time, the first thing you do, step one, is to write the formula. And hopefully you're writing this down. The formula is area equals base times height divided by 2, or area equals half times base times height, because half of a square is a triangle. Okay. Then the second thing that you do is use substitute values for the variables. So substitute 5 inches for the base, substitute 8 inches for the height. Okay. The third thing you do is multiply. And then of course the last thing you do is divide. The reason why we divide is because you're dividing by 2. All right, there's your steps, guys. All right, so for this example, we're gonna find the missing dimension. So we're gonna find the base value of this triangle. Again, triangle means 3 angles. Here's one acute angle, another acute angle, and a third acute angle. 1, 2, 3 angles for that triangle. Okay. All right, so we're finding the missing dimension. So again, a dimension would be one dimensional would be the length. That's your x-axis. Another dimension would be your height. That is your y-axis. So this is 2-dimensional. So the length's 1-dimensional, the height is 1-dimensional. Okay. So if I have a 2-dimensional object here, you know, I have a parallelogram, I have a square. Okay. But if I add I'm using the x-axis and the y-axis because I have a length and a height. But if I add, and I'm talking about dimensions, by the way, and if I add the depth, well, if I add depth here, then I would have the z-axis, okay? And then, of course, I would have a 3-dimensional object. So the z-axis is also 1-dimensional, and that is the depth. So a 3-dimensional cube, okay, so a cube's 3-dimensional. So again, you have your x-axis, your y-axis, and your z-axis, x, y, z. Your x-axis is your length, your y-axis is your height, and your z-axis is the depth. So that's a 3-dimensional object there, okay? But we're only working with 2 dimensions, the length and the height here for this triangle. So this is a 2-dimensional figure. There is no depth, okay? So to find the missing dimension here, we don't know what the base value is. So we're just gonna put B here for the base. We do know that the height is 12 millimeters, and we do know that the area is 56 millimeters squared. So again, the first thing we do is write the formula. The area equals half of a, so our triangle is half of a square, and the formula for a square is base times height. So half of a square, okay? So the area here is 56 millimeters, so we just substitute for these values. We don't know what the base is, so we'll just put B there for now, but we do know that the height is 12, okay? And then from here, you just multiply or simplify. So you know that if you multiply 12 times half, that is going to be 6. And then B is by itself. And then, of course, just like last time, we were solving equations. So the inverse operation of multiplication, because anytime you have a coefficient and a variable, you multiply. So the opposite that undoes multiplication is division. So we divide by 6. We want to isolate that variable b. 6 divided by 6 is 1, so b is by itself. Now you have 56 divided by 6 here, okay? So let's find that out. Let's do simple division here. Okay, so 56 divided by 6. Well, let's see here. I do know that 9 times 6 that would be 54. 9 times 6. So 6 times 9. And then that's 54. We have 2 remaining. And we want to keep going. So we're just going to annex 0. Bring that down. 6 can go into 20 about 3 times. That's 18. 2. Bring annex 0, bring it down. So it's just going to keep repeating. Okay, so I'm just going to do that because 18, 2, and then annex 0. It's just going to keep repeating. So I put a bar on top of the 3 there. Okay, but if I were to go from a decimal point number to a fraction, this would be 9 1/3. That would be the value for B. So this would be 9 1/3 millimeters. Okay, simple as that. But if you want to verify, you can check this. Okay, so we're gonna check real quick, and it should match. Now the area equals I guess half of the base times height. Okay, 56 is the area, half, and then we're saying the base is 9 1/3 times 12. Okay, so now we're gonna have 9 1/3 here times 12. Okay, so we're gonna go 9 times 3. 9 times 3 is going to be 27 plus 1 is 28 over 3 times 12. Okay, so 28, let's see here, 28 times 12 would be about 336 over 3. So half times 336 over 3. All right. And then, of course, let's just simplify this. So 336 divided by 3, that would be, let's see, 112. Okay, and then we just multiply that times half. So 112 times 0.5 would be 56. 56 is equivalent to 56, so that checks. All right, so that works, and the dimension for the base for this triangle is 9 1/3 millimeters. All right, there you guys go. And let's go ahead and move on to the next one. All right, the last question and example we're going to do is modeling real life. So let me read to you guys. We're going to find the area of the fairway between 2 streams on a golf course. So I do like these problems that are given to us in the textbooks, but you know, out here on the Navajo Nation and Hopi Nation, you know, we don't really have golf courses. So a lot of these problems, you know, don't really make sense to a lot of us because, you know, maybe we've never set foot on a golf course. So these questions do need to be changed. Okay, so maybe one of you guys would one day, you know, write the math problems and, you know, be in charge of that and have your own company or even make golf courses here. All right. So here we go. So we're going to find the area of the fairway between the 2 streams on a golf course. So right here, guys, this is called a composite figure. Okay. So here's one stream of water here. Here's another stream of water. Okay. And here we have dimensions. 70 yards, 40 yards, 40 yards, 40 yards, 50 yards. So again, this composite figure, you want to break this into different shapes. So if I look at this again, and I want to make this easier. So if I look at this shape, I know that this is a square or a rectangle, and this is a triangle. So I do know that the formula for a square is area equals base times height. This is going to be the area of a square. And the area formula of a triangle, is going to be area equals base times height divided by 2. Okay. So let's look here. So if this top here is 40 yards, then the base is 40 yards. times the height, 70 yards. Okay. Now, 40 times 70, that's going to be 280 yards squared. Let's see here, wait, 40 times 70. Nope. 2,800 yards squared. Okay. And yeah, there you go. And then we just find a small one. So again, the base here is 40 yards times, all right, so for here's 10, 20, 30, 40 yards. 10, 20, 30 times 30 yards divided by 2. Okay. So 40 times 30, that's going to be 1,200 yards squared divided by 2. So if we divide that, it's going to be 600 yards. Oops. Squared. Okay, so this little triangle here is 600 yards squared. This big rectangle is 2,800 yards squared. But we want to find the area of this whole fairway here. So all we do is add them together. Okay. So 2,800 yards squared plus 600 yards squared. 0 plus 0, 0, 0 plus 0, 0. 8 plus 6 is going to be 14. 1 plus 2 is 3. So the area of that fairway between the two streams is a total of 3,400 square yards. All this space inside. All right. So there you guys go. And that's really all there is to it. Again, just don't get it mixed up that triangles and squares are different. They're very much the same, but just remember that in every square, you can definitely find triangles. All right. So again, here you go. For 7.2 areas of triangles, by now you should be able to explain the area of a parallelogram and how to use that to find the area of a triangle. Now a parallelogram, 4 sides, 4 vertices, 4 edges, 1 face. It's because it's 2-dimensional. That is area equals base times height. And of course, to find the area of a triangle, half of a square is, of course, a triangle. Okay, so that's your formula for a triangle. Also, by now you should be able to use the base and the height of a triangle to find its area. You should also be able to use the area of a triangle and one of its dimensions to find the other dimension, like what we just did earlier. And also use decomposition to find the area of a figure. So what we did here was we decompose this composite figure into a rectangle and into a triangle using these two area formulas and added them together at the end to find the whole area of the fairway. All right, well, there you go, my friends. Don't forget to ask for help, okay? And this is what we're here for. And just remember that we do want you guys to get your assignments in as much as you guys can, because next week, Friday, the third quarter is ending, okay? So final grades are going to be due for third quarter next week. So please chip away at it this weekend and get everything in, get caught up. All right, you guys can do it. Ask for help, and there's tutoring sessions available. There's Saturday school as well, and we'll see you guys later.